Hello! Today I would like to talk about recursion or recursive functions in programming in Python. And I think Fibonacci is a very good example to understand recursion. What is a Fibonacci series? It is a number series that starts with 1 and continues with 1. And from now on, it continues as a summation of the previous two numbers. So 1 plus 1, the next number is 2. 1 plus 2, the next number is 3. 2 plus 3, the next number is 5. 3 plus 5, the next number is 8. 5 plus 8, the next number is 13, 21, and so on. And understood the point of Fibonacci function, you just want to give a number to a function and get the respective value in the Fibonacci sequence. For example, if you give 0 as an input to your Fibonacci function, you should get 1. If you give 1 as an input to your Fibonacci function, you should get 1. So it means that if I give those n's, the respective n's, for example, n equal to 5 to my Fibonacci function f5, then I should get the number 8. If my n is equal to 6 as an input to my Fibonacci function, then I should get 13. You got the point. The rule was to start with f2 as a summation of the previous two elements. So f2 is actually equal to f0 and f1. f3 is equal to f1, f2, and so on. And the rule, if I write it as a series, the rule of the series, then I have my fn is equal to my fn minus 2 and fn minus 1. And the reason why we call it recursive function or recursion, because to calculate the value of the function, we need to calculate the function again. So the function needs itself. The calculation step recursively calls the function itself. But we still have some sort of problems here. With every recursive function, that is something that you have to think about, the initial values. For example, if I want to reach f0, then I need f2, f minus 2 and f minus 1. The same for f1. If I want to get f1, yes, I have f0 here, but I do not have f minus 1 or f minus 2. But those are just two numbers, and they are not very difficult to initially define it. So if I just say that f0 is 1 and f1 is 1, I have all the initial values that I need, and I can write my code now. Okay, so if I put my rule on the right-hand side, and if I start writing the code on the left-hand side on my Visual Studio Code, first I need to define my Fibonacci function. You can give any other name to your function, but I think Fibonacci is quite a representative. And if I give n as an input, I should get the respective number here. But as I explained, here until n equal to 2, it is very easy. Then I need to just start writing an if statement when my n is equal to 0, or if the n is equal to 1, I have the exact number. I don't need to calculate anything, which is going to be returning 1. This is as simple. So if n is equal to 0 or 1, I can immediately return 1. However, if I have anything else than 0 and 1, then I should calculate this. And how was it? Then I should return recursively calling the function itself. So Fibonacci n minus 2 plus Fibonacci n minus 1. So this is the written format, the code of what we have discussed here. Let's check this one. So I'm trying to find, for example, Fibonacci, let's say Fibonacci n equal to 4. Am I gonna get 5 here? Fibonacci 4, and I can just print this. If I run that, yes, I get 5. What about if I want to get Fibonacci n 9? I can try this here. Run it. I get 55. It seems like my function is working. But what if I am interested in getting the whole list until that number? So instead of, when I write 9, instead of getting 55, if I want to get the whole all of the numbers until 55, how can we do that? So that I can use lists. I can first create an empty Fibonacci list, and I can return that list instead. Right now it is quite useless because I haven't done anything with my Fibonacci list yet, but also one way or another, until I reach this return, my function will return something else. That's why it is shaded away. I need to change something here. But the rule or the condition is the same, so there's nothing that I need to change in here. In if and else statements, I mean. But I'm not going to return a single number. I'm going to recursively iterate in the elements of the list. What do I mean? So I will try to reach the elements of the Fibonacci list from 0 to whatever the number. So we need all of them before we return something. And to do that, I need to define a loop for, let's say, I is equal to, in the range of n, so until n, I will do all of these all the way from 0 to n to whatever number that I give. It is always gonna start from 0. In the previous one, we were just returning a single number. That's why we didn't need to keep all the previous values, then we didn't need the list. But now I'm interested in all the numbers until the calculation returns you something. Then the condition is still the same until I reach n equal to whatever number here. As long as it is equal to 0 or 1, it is gonna, the result will be the same, but it's not gonna return it. It is instead gonna add or append into our list. The same, it is not gonna return, but it's gonna append into our Fibonacci list. But this time, instead of calling the function, it is gonna reach the previous elements of that list. And now my return is not shaded away anymore because there's nothing returning before that, and the whole list is now returned. Let's try if it's working. Oh, sorry, I'm still using the function parentheses. So we are trying to reach to an element of a list, and we need to use square brackets. And I can try one more time. Yeah, it seems like it's working. By the way, it hasn't returned the value itself because we are just in the range function. We are not considering the number itself. So it is calculating the Fibonacci series until that number. If you want to include that number, you can always add +1 here and return it. Then you will get your number as well, because your number is also included in this for loop. I hope it was useful. Although it is a quite short code, it is a little bit challenging to think about. If you have any questions, I will be very happy to answer. You can always come to my room, or you can write me on Discord, on YouTube, or mail, and anywhere else, or in anywhere, I mean. So good luck. See you.